everyone, today we are going to solve the question house robber 2. So it's pretty similar to the question house robber 1, but here we have the case that the houses are here currently arranged in a circle. So what that actually means for us is that the last house cannot be adjacent to the first house, vice versa the first house cannot be adjacent to the last house. For example, in this test case, what was the earlier catch? That if we are if our I index is at house 0, that is at house with money 2, then we could jump to the index 2. But now that the circle case is here, so we cannot jump from 2 to this 2, because when we look at the circle, this 2 is circularly connected to the n2, therefore they are adjacent to each other and cannot be selected at the same time. Therefore we will be left no choice but to select this 3. So this is the catch here in house robber 2 compared to the house robber 1. So the main point here is that the first and the last one are not adjacent to each other, which means that if we want first in our answer, then we have to go from 1 to n minus 1. Why? Because we cannot choose this one. Just like that, if we want the second term in our answer, then we will have to go from 1 we have to go from 2 to n. Why? Because we can't have 1 in our answer. So that's the main logic here. So let's code it up for now. So our code is going to be, first of all I will write the code for house robber 1, then I'll make changes to it to make it like house robber 2. So let's write the code. So I will make a function, suppose called solve. First I will int n is equals to nums dot size, and I will make a function solve which takes nums, and what are the two from, suppose here it's 1 to n, so we will have to take two parameters. That is suppose we for this case we are going from 0 to n minus 1, and in that case we are going from 1 to n plus. So the parameters are going, for example, for if we are including the first term in our answer, then it's going to be 0 to n minus 2, and if we are going to include the second term in our answer, then it will be just n minus 1. And the catch here is we are solving two iteration of the function, so we are going to choose the most optimal one. For example, here also, if we will choose this as our first term, then we will have no choice but to choose to steal this, that is the answer will be 3. Just like that, we have two choices, therefore we will solve this, then we will solve this, and we will find the maximum of this. Why? Because we want to choose the maximum answer. So what I'm just gonna do, return max of this comma this. And I'll just remove this for now. So let's build our solve function and solve. What are the parameters here? So I'll just take this same as my parameter, and I and int n, which is pointing to our n, that is the size of the nums. So what we need to do now here is, let's make our base case that if I is less than equals to n, then we are just gonna return 0. So let's make our variables here how we used to do in the house robber one. It will be int steal is equals to nums of I plus solve of nums comma uh, I plus 2 comma n, and similarly int skip is equals to, we just gonna go one step further because we are just skipping it. It will be just I plus 1 comma n, and at the end what we are gonna do, return max of steal comma skip. So this is a recursion method. I would like to run it and see if this works or not. I hope it works. Okay, there is a error here, type in cannot bind a temporary type int. Okay, so what it tells is that, so yeah, actually fixed the problem. The problem was that I was going from 0 to n minus 2, but in reality I was supposed to go from 0 to n minus 1, and here 1 to n. So yeah, let's try to run it. Okay, this runs, but if we try to submit it, there is a good chance that time limit exceeded would be there, because yeah, okay, so I have to make another test case that if I, is it I, right? No, I can just make it here. If n is equals to 1, then I'm just gonna return nums of 0. So let's try to, okay, it will be 1, but let's try to sum. There's a good chance there will be a time limited exceeded error because this is a basic recursion. Okay, yeah, so time limit got exceeded because this is a basic recursion method, and the kind of time complexity of recursion is very high, 2 to the power n. So let's try to now use memoization. For that I'll make a vector here and dp whose size is n plus 1. Let's make everyone minus 1 for now, and here I will have to pass dp, here also dp, and I have to make another function here. I'll make a new parameter here as well, dp, and let's save it. So if dp of I is not is equals to minus 1, which means that we have actually seen this value, and we are just gonna return it, dp of I, and let's save it somewhere, that is return dp of I is equals to max. So let's see if this works. I hope it does. So okay, I wrote here d only, it should be dp, it was a typo problem. So what error am I saying here is that, okay, here also I am supposed to pass dp, here also dp, Now let's check. Okay, it works. And if I were to submit this, then I think this will work because the time complexity have been reduced. Okay, so the memory limit exceeded here. Now how to solve this memory limit exceeded, we are going to see that in the next video. We are going to solve this using a bottom up approach, because memoization in itself is can be a very space complex size. So yeah, we are gonna see that in the next video. Thank you.